Thanks, everyone. I always love coming back to campus to see some old familiar faces and meet new friends, but also because it's exciting to see how many cool energy-related centers and research groups and projects and classes there are today. I studied civil engineering before, and Gil's here. Gil Masters is one of my most inspirational professors, and Professor Tatum's here too, and I see him too. But there weren't that many options back then. There were really exciting options, but for instance, the civil engineering department, it was either wet or dry. It was like structural or water, which are both really important topics, but now I know there's a lot of other disciplines and you know, subspecialties there, and I know there's a lot of movements across interdisciplinary classes and projects and working with real industry partners and all of that. All of that's really exciting. So every time I come, I actually learn something, which is not true of, for instance, when I go to like industry conferences and stuff, you know. So this is where I come to learn the good stuff. So anyway, my topic today is focused on getting to point A, and the reason it's titled that is because despite my 6 years of education here and 8 years of work experience, I feel like it's just time to get started. And I think that's emblematic of the challenge that we're all facing and the opportunity we're facing with overhauling the industries of power and even water and just the resources that helped industrialize and get our country to where it is, but now need some fixing. So like the journey, I'm just going to kind of talk about this sort of journey to just show an example of how complicated this issue is and how all of you, as you're studying or thinking about how you want to tackle these problems, to encourage always not just assuming there's one answer or one skill or one approach that's going to make it work. It's actually a combination of many things and finding the right folks to do it with. So so Google started there, well, mostly started there, some energy efficiency, mostly focused on greening buildings at Google with solar, energy efficiency overhauls, you know, non-toxic environments. That was one thing. And then in between my business school years, you know, went to the government and thought, okay, maybe there's tons of money in 2009, like being flooded into the market from the Recovery Act. Let's go see how the government can really change things. And then after business school, clearly I was not quite ready to stop. I don't know, I left the country, I guess is the best way to say it, because I felt like the answers were elsewhere, and predominantly in Europe, and where there was, you know, in Denmark, there is a very renewable energy powered grid. It seemed like they had gotten the memo a little bit faster than we had, and the need to like test out new theories, put new infrastructure out there, and just kind of like impose renewables. And then there, though, it was still a question of how can we build more big power plants? You know, building a wind farm is, it's sort of like developing a natural gas thermal plant. And it seemed like even though there was this whole industry that had organized around it, supply chain, manufacturing, you know, it was competitive, it still wasn't quite making the dent in changing how we assume power is being generated or used or supplied. So then I came back and actually worked for Dean Kamen, who is, if any of you guys know who he is, he's a famed inventor who always looks at how things are and just saying, that's weird, I'm gonna fix it. And so he did it with insulin delivery. You know, before, if you were diabetic, you'd have to go to the hospital to get your injections, and he developed a cool, neat auto syringe that improved your daily life. Or, you know, he's doing that with dialysis. Most people knew him as the Segway inventor. And then what I worked on with him was, you know, a distributed generator and then a distributed water technology. And there are two very straightforward technologies. They're very specific, and they could change a lot of lives. But still, despite like going for solar or going for wind, going for government, going for a certain technology, it was too hard to get that big change accomplished. And so throughout all of this, beyond just the experience, from the technology experience, from the policy, all of that, all you needed to what I was starting to realize was it's way more complicated. So we needed to kind of do more things all at once. And so having an opportunity to come to NRG to say, look, you have this whole broad platform of, you know, if you're a company that's building power plants or trying to deliver retail electricity to end customers or develop an electric vehicle charging infrastructure, that's a perspective that is very complicated and not very many people have. And then you throw on a threatened business model on it, then there's real impetus for change. So that is kind of the professional journey I took to see, let's try to implement real solutions in the world. And it still took that long to figure out, you know, how can I be ready to actually do something? And then, of course, I couldn't do this without my lovely education from Stanford, which promotes, you know, a lot of interdisciplinary thinking, challenging status quo, and you know, real cold, hard technical skills and strategic business thinking. But all of this is in kind of packages together, starting to understand what are the tools out there, and then let's go do something. So, of course, all of this with all this renewable energy training and a cutting-edge Silicon Valley education, it landed me at an abandoned power plant, which is obviously a logical progression. So here's actually is Station A. So this is the team I founded for NRG. When my CEO, David Crane, said, hey, go start up an internal disruptor team for NRG. We're worried about, you know, the future of the utility industry. He said, go out to Silicon Valley, find a fancy office that's really cool, and like build a team and like do something Silicon Valley-ish. And so I looked at some offices in downtown San Francisco where there was a lot of very expensive, innovative, collaborative spaces being marketed to me. And all I could tell it was like open floor plan with an exposed brick wall and some primary colors and a carpet. And you know, it wasn't that inspiring. And then I found out NRG owned this retired power plant in the Dogpatch neighborhood. So luckily still had some hard hats from my civil engineering days and talked my way in and figured out that, you know, it was there and it wasn't a super fun site and it would be healthy enough for us to work on. So, so that's when I called David Crane and said, all right, first decision made. I found the Station A office. So from that point on, it was this kind of question of how do you build an innovative team in this old school industry when, you know, you actually don't know exactly what you're doing, and to be honest, you've never done it before. So, so first I just focused on what I knew, which is designing a building. And so I started designing an office and a team at the same time, and what was interesting was that informed how we wanted to actually solve a problem. So if you're actually designing space, and I'm saying this for a reason because it's going to come in handy later. So if you're designing space and you're designing, you have to answer questions like, you know, how are you going to use that space? You know, how are your teams going to interact with each other? What kind of people are you going to have? What kind of space? You know, you're like forecasting and predicting this kind of like new method of work. And it was great because then it forced me to think, all right, what are we actually trying to solve and how should we work to do it? And then that goes back to inform the space. And so we built that in 3 months. The first part of the team showed up and we were ready to rock. And it's very beautiful and really cool. And what's really cool is that we have this elegant kind of reflection of the past reminding us of what we're trying to do. And we look at this and see beauty. This old power plant is incredible, and it electrified America. And that's something we think about all the time. And as we're now trying to figure out how to re-electrify America or, you know, the world, we can't forget how hard it was to get to a point where that was opening and closing. So that's another very poetic moment for us as we try to, you know, solve hard problems. So the philosophy of Station A is something that probably all of you guys are really familiar with too, but in our industry, this is sort of not as familiar. So the existing power and electrical grid is kind of a mixture between a centralized and a decentralized grid. And this worked really well for about, you know, since the 30s. And it was very important. But now, as we have more small things, like distributed energy resources that are going to proliferate everywhere, whether it's rooftop solar, whether it's, you know, more smart automated loads, or, you know, storage is a hot topic right now. This is going to become less robust and less resilient for supplying 99.99% reliable electricity needs. So Station A wants, we like to think about if we could redesign the grid from scratch, how would we design it? And we like to think about a truly distributed network of these distributed energy resources. And so this is kind of our philosophy on how we can keep pushing the envelope or overhauling the conventional wisdom around how you should design to supply things. Another big kind of inspiration for us is from nature, and this is a strawberry plant that kind of is going to showcase our belief in how distributed systems, whether it's a microgrid or a solar array or individual things, can work in conjunction with each other or on their own. So a strawberry plant can grow on its own, or it can also sprout out these little shoots that help connect to other new strawberry plants, and you build a strawberry patch, which is like a very great, resilient, distributed grid. If one strawberry plant dies, then the rest of the patch is fine. And if one strawberry plant is only by itself, it can also survive. So this is even more powerful to us as a philosophy or our design challenge, which is how can you design a world of distributed things, whether it's supply of electricity or balanced systems that can operate all on their own or operate as a new highly distributed network. So, and then that informs the business model around it, which is what are you actually trying to do with those systems? So it's no longer just about how do we produce and supply as many kilowatt hours as possible. It's kind of shifting the mindset to realizing we actually need to optimize these resources. So this system the assumption is that there are always going to be resources available for you to supply and distribute as much electricity as you need. So it's more about optimizing supply. Or not optimizing supply, it's just like producing as much supply as possible and getting it out there so that it's always there. And that's based on the assumption that resources are always there. But this is more based on the assumption that resources won't always be there and you need to use them assuming they can never go away. So going from a supply model to an optimization model is the shift. And that changes, and that's based on all of the input we have now in terms of supply challenges, the economic realities of, and the environmental realities of how things are done, and just understanding that there is a more intelligent, better system out there. So this is really, too, what this is what inspires us, and this leads to how we try to solve these technical and business problems. So that leads us to Station A. And again, just sort of, this is kind of a long journey because it took us about a year and a half to get here, to be honest. Station A, we're a product development team for distributed energy solutions that NRG can grow businesses around. So we're an internal startup, but we're there to help grow a business for NRG. We leverage a lot of things that already existed in our industry, but also some new things. So engineering, clearly, is engineering strategy is probably what we're leveraging from what the industry had proven. So the Rural Electrification Act and scaling a huge power just infrastructure network was both a feat of engineering, as a feat of strategy, and understanding how people's lives were going to improve by having electricity, and also some neat business models around it. So that was an epic feat that electrified our country in 15 years, and or the rest of the rural part of the country in 15 years, and that's something we will leverage. In addition to that, there's a few things that the industry is just starting to get used to. One is data and analytics, and the other is software development. So I know this is a highly informed group, so sorry if this sounds obvious, but a lot of our electrical infrastructure out there actually is not that intelligent. If there's a power outage, it's hard to know exactly where it occurred. And there hasn't been a culture or even the infrastructure to enable pinpointing things or understanding exactly what's going on. So now there's a new wave of focus on data and analytics and building out the back-end infrastructure to support that, as well as software development to enable and automate a lot of things as these new distributed systems get out there. What also is interesting is as you start to bring, centralized power plants and make them smaller and smaller and smaller where people are using it, you're starting to fuse infrastructure with the built environment. So you can't just have a building that's designed and then assume there's an electrical connection going into that building. You actually need to design it all in an integrated fashion. And as you start thinking about buildings, then you start thinking about communities, and that starts bringing in urban planners and architects into the room. So this is a very new thing where it's not just like, what is the electrical code I have to design to as an architect? It's thinking about how do these systems impact how humans interact in the built environment around them. And in many cases, the word kilowatt hour doesn't even come up. And so that lends to urban planning and design. Because as we know, sometimes we get picky about design, and we want to live in a beautiful, happy space, and that makes us healthy and enjoy the world and all of that. So at some point, this circle is starting to mesh away from a kilowatt hour or a levelized cost of energy. It's getting to how our world feels with these new types of systems. And then so here's an example. This is our team. All of the folks here have different backgrounds that meet those different circles, and then we work collaboratively or individually to try to make sure this happens. And it's anyone from the guy on the sailboat actually used to run the power plant where we work right now, and he actually knows more about reliability and the urgency of that than anyone, because he was there keeping it going during the Loma Prieta earthquake, to brand new recent grads who have had the luxury of studying a lot of this new energy thinking and helping educate us on all of it. So this is kind of our small ragtag team that's trying to make sure we're thinking about all those circles as we design products that can be implemented in our built environment right now. So one example, which is obviously a very extreme example of this type of systems we think about, is an 80% renewable energy grid we've designed for Richard Branson and his Necker Island and the British Virgin Islands. And this sounds very extreme, I know, but you actually need a very risk-taking, progressive partner to design these type of new systems. So what we've done is, so this is an island. It's run as a resort, and so it has a really interesting load profile. But we've basically developed a solar, wind, battery, and load balanced system that reduces their diesel consumption by 80%. And the diesel generators they have has been powering the island for 20 years. They call them Old Faithful. They're very reliable. So it's like stiff competition to our renewable energy grid. So this is an example of how there's so many different things that go into just building a new renewable energy grid. So first, obviously we had to design the system. And a lot of these parts are very familiar, but the sum of the parts are actually, that's kind of new. And finding the optimal integration, making sure you have the right sizing of the different components, having the faith in that it's actually gonna stay up. All of that had to go into the design of the system. When you design a new system, that often means you're delivering a different kind of service, and there's a different business model that goes with it. So this is kind of a new example. This is an example of that, looking at optimized use of resources. As many of you guys know, the solar world is mostly based on power purchase agreements, as is the traditional electricity world too. So you're paid per every kilowatt hour that your end user consumes, which is that volume-based commodity model. Here, since we're going to be balancing across, we want to maximize renewables. You want to match your supply of renewables to the loads. And so that means load shifting. And you want a lot of information so that you always know what's going on, even when you're very far away. There's you want to get paid differently because you wouldn't get rewarded for energy efficiency or balancing. You'd actually get harmed for it financially. So we worked on a new kind of, we called it a diesel reduction agreement. So we're actually getting paid for the avoided cost of the avoided gallon of diesel that we're not using anymore. So it's like a ESCO model with energy efficiency. So you have to baseline your diesel, and you have to measure it, and do that kind of calculation. But in that sense, it's rewarding your elegant optimization as opposed to just like jacking up the wind turbine whenever it's windy and curtailing. So, so that was part of we actually had to deal with that up front as we were designing the brand new system. Then we had to build it, which is more straightforward but hard because it's really far away on a remote island, and you have to be careful about a lot of things. And it has to be cost effective. So while all these components are available and proven and tested now, a lot of them are still cost prohibitive or just way too expensive. So again, that informs your design to optimize around the right cost measurements and you know, making sure you're not oversizing if you can kind of deal with the load a little bit differently, for instance. And then finally, once that's all going to be built, we need to communicate it. Like, what is this thing? So for us who think about energy all the time, you know, 80% renewables, this many kilowatt hours, this much reduction, these CO2 metrics. But at some point, you know, people are going to really want to know why it was worth all this trouble. And so thinking beyond just the kilowatt hour and that communication level is really important for us too, especially so we need the client to be happy. So if Richard Branson looks at his phone, he's getting what he needs. But then B, there's a lot of guests coming to this island who are all well-informed or different types of stakeholders or who've seen a lot in the world. So communicating to a lot of different stakeholders is really important too, because then we can get a lot of good feedback about how people feel about these systems. That's just a little rendering of what I talked about. So then just as another kind of design thing that pops up, you know, the color of the wind turbine came up. And this was funny because it was kind of timed around that whole like white versus gold dress, blue versus black dress thing. But, you know, color theory is a little important. And so we were asked to deliver a turbine the color of sky, which is very hard. But I think it's a beautiful question from a customer. So this is, you know, that case study was important to demonstrate a concrete thing. It's very complicated, very remote, very extreme, but it's actually really helped inform a more kind of tangible product roadmap for the team that's going to scale anything from incremental upgrades to distributed energy to urban scale district energy and water solutions, which, by the way, there are people out in the world asking all of these questions, needing all of these things right now. So it's no longer a question about is it going to happen or not. It's happening. It's about how fast we can get to real offerings and solutions and kind of answering some of these questions that people really need answered. It's not just like a fun intellectual exercise. So at Station A, you know, we're focusing on our product roadmap, and the way we're trying to tackle it beyond just, you know, here's the technical solution. You know, you always have that question about build versus buy, or, you know, what are the strengths of your own organization to get stuff out there fast and, you know, learn and deliver better service. And so we really like to think of ourselves as integrators and knitting together a lot of things out there. So in the world of, you know, startups and focus and venture-backed models, there's a lot of partners out there that have one thing they're really good at, which is how that funding and investment model works. And it makes sense if you're CEO of a startup with investors, you gotta show and prove really fast and scale one thing. So we're in the privileged position of seeing a lot of those really good things that we can bring into the room together and try to create a better, more integrated solution. So partnership development, doing in-house engineering to knit together is really important. And then a lot of having that inform a lot of strategy and internal stakeholder buy-in to let us keep doing what we're doing is really critical. The packaging of the products, this is kind of to that design. Packaging can mean a lot of things, but there's some people who will never want to talk about kilowatt hours. There are some people that are only going to want to talk about round trip efficiency. And so understanding how you can kind of productize these things from more of a like audience level, eventually an aesthetic level, eventually just re-engaging with the human behavior level. There's a lot of time spent around that. And then finally, right now, what we're focusing on is getting a lot of these product ideas and concepts and prototypes into the field so that there's real proof points to show it works and it's time to scale. So 2016, I hope next we'll be able to say we have all these products that like made it out of the funnel okay and they're real businesses. But right now, it's really, this is what we're focusing on. And again, I'm trying to showcase this because getting to point A, where you can actually start doing stuff, can take a while, even though at first, and there's a lot of learn, like often when you're in the middle of it, you can think, this is the answer, I just need to make this happen right now, and that's gonna answer a lot of questions. But in a world that's complex with either failing infrastructure or infrastructure that doesn't exist, in an industry that is very powerful and has a lot of power and influence, but also is also facing a lot of change, it's kind of a whole new set of tools and answers you need to bring and a different style that you need to bring. So that's how we're trying to do it. It's respecting the past, but always focusing on the future, listening to everyone, kind of integrating all of this together and realizing that the distributed model means that things start converging more, like all these worlds we didn't think about before in the context of energy. So that's kind of what I was coming to say today. I'm more excited that this room has so many people who want to go work on this problem. So a lot of this is about trying to get everyone excited still to keep doing it, because we need more and more amazing, smart talent out there solving these hard problems. Thanks, everyone.
Okay, questions, and we'll start with the students like usual. Okay, students. Okay, how about over there? Yeah, you. Yeah.
Hi. What are some challenges that come with this new distributed system that weren't present in the previously available systems?
Yeah, we were sort of just talking about this before. I think there's a lot of, I don't know if it's challenges in terms of technical challenges. There's enough people out there if we threw them at it, whether it was the power engineering side, the data engineering side, the software engineering side, like all of that can be figured out. The challenge is probably more from the investment and money side. So who's going to fund that? Who's going to want to control it? Who's going to want the outcomes? And then also the policy side. So if in our future world of every building being its own thing and sharing across, everything is illegal right now. So there's a lot of that work to do too. So both regulatory to me is daunting because I don't understand that world as much, and it's really important. And it's going to require a lot of proactive regulatory work as opposed to reactive regulatory work.
So do you have an attorney yet?
Yeah. Yeah. Never mind, I was going to say a joke. I can't remember.
There might be somebody here who wants a job. So anyway, okay, more students. Yes, please.
I was wondering about challenges and solutions that you found in the small-scale project on the island that you think will be important when you scale it up, let's say in the bigger system. What are the main things, challenges and also solutions?
Yeah, great question. So if we're assuming there's a bunch of Necker islands on the mainland that we're trying to scale up at different scales, one of the fun kind of rewarding insights we got was the importance of matching load with supply and being able to shift things around based on how windy it is or how sunny it is or what's going on. And so just having that insight and information is like fun because you can start like matching things differently. And that translates into economic benefit and reliability and prevents you from having to oversize that system. So you don't have to always just like oversize to ensure it's always there just in case of the worst case scenario. You can just be way more delicate and elegant about it. So on Necker, we actually match, we took control of the reverse osmosis system. So we pretty much only produce clean water with the sun and wind now. And then it's way easier to add a water tank for storage than an extra lithium-ion battery, and way cheaper. So there's like neat tricks like that come out. And I think that could definitely be applied at different scales from building all the way up to neighborhood and community scale. Challenges will be, the bigger you get with a lot of more little things, the more complicated the problem. And but again, I think that's all solvable, but it's solvable and, if you put the grunt work in on the technology and the engineering side, but in the math side, but convincing, for instance, an industry that has looked at IT as an expense into investing in IT infrastructure and software is the classic conundrum of overhauling industries, but it's the energy industry is going to have to go through it.
Okay, students, yeah, go ahead.
How did you choose your team?
Great question. So it's pretty organic, but I knew there's a few specific skills and disciplines I needed represented. But a lot of it was about fit and, well, passion, of course, because this is it's daunting. You need to be really excited about this. And there's a cultural fit too. The being collaborative and also able to be confident in your own work and convincing other people that you're right is actually, it's a big deal because we're just trying to go as quickly as possible too. When we first started as a team, everyone at the company thought we were just this R&D team that was playing around with 10-year ideas, and it's not that at all. It's way more accelerated and just showing, improving, and trying stuff out. So having that kind of risk-taking mentality and constantly believing that hard stuff can happen is really important. And it's an amazing screen because there's a lot of folks out there that think it's a cool idea, but the level of commitment and just blind stubbornness to come and do this is important.
Okay, we'll get to other people. More students? Yeah. Okay, please.
Who paid for the investment on this project, and is the investor getting a return on it ever, or?
Yeah. So this, the Necker Island project's a partnership with Virgin and NRG together, and it's not like a conventional finance project thing, but it's a very strong R&D and product development investment. The goal, obviously, is to get it to a point where you can standardize financing around it and just scale it all out. And I don't think it'll be too long to get to there.
Okay, anyway, more students? Yeah, go ahead, back there.
So with energy demands not being distributed uniformly in any area, electricity demands being ununiform, and such as water and also, do you foresee in your distributed model that the model will be smart enough to, first of all, recognize this uneven demand, and then without any, with automation, will it be able to, transfer all the energy demands accordingly based on the ununiform demand in the area?
Yes. No. Yeah, no, absolutely. All of that needs to happen. So there are, like I said, there's a lot of pieces out there. Folks have been really focused on demand-side management, which is disaggregating loads and being thoughtful about when you use stuff to, automated control of those loads. And then obviously now we have distributed supply and automated control of those supplies. And then there's this whole fun control theory problem to make sure the right one, the marching orders are coming in at the right level and doing what the end user really needs. And so another challenge or implication there, I should say, is it's really important who the end user is and what your goal is. So kind of the backdrop of all of this, of course, is democratizing energy and trying to bust up a lot of the kind of monopolistic regulated industries out there. And I know it's not going to be one way or another. It's going to be a mixture. And we actually work with some utilities on this stuff too, because some of them are really getting it. So that kind of marching order information, demand chain is, it'll be different based on who we're designing things for. So that part's going to be also pretty interesting.
Okay, students, and then we'll go to you. I promise after you're a student. Yeah, okay, yeah, please.
How much does Station A consider water infrastructure and energy requirements for water within this?
Yeah, we love water. You could put all the same slides for water, basically. But we do look through the lens of electricity to reach the water infrastructure side and understand how this, this can all of the theory of distributed networks can benefit everything. And as we all, the whole you can't just design water in a silo and electricity in a silo and thermal energy in a silo. It all has to be designed from an integrative approach. And electricity from our perspective is a neat way to do that, especially because a lot of water management loads or treatment loads or production loads are, very energy intensive, both at a distributed and centralized level. There's a neat interplay with electricity there. But yeah, I feel like water it's a big deal for us. We just designed a little off-grid water modular home on our power plant site. We have a lot of space, so we can do some stuff. But we wanted to capture rainwater, which hopefully we'll get some soon, and then treat it to potable water. And there was no permitting application in the city of San Francisco to do that. So again, that was also technically illegal to do. And we worked with the city to develop an application, and then we filled it out. And then now we have it. We have no water, but yeah, so stuff like that. Right now, we're trying to push the envelope there, but it'll become a much more prominent thing for our systems, for sure.
Okay, all right, how about you?
Yeah, thank you for the very innovative presentation. One question, you see yourself in terms of the Necker Island work, are you going to develop systems on a community by basis, or are you going to develop sort of a common system for a particular community in a particular geographical area? And in either case, what is your value proposition to existing customers or an existing community?
Yeah.
Like, why should somebody come to you or community come to you versus just going to Solar City and getting an individual power?
Yeah. Yeah, so I think there's a few questions in there, but so first, our goal is to try to make this approach as plug and play as possible, and we'll never get to a purely standardized, like, microgrid in a box world. People are going to try it, I know it, and it's happening, and we are partners with some of them, but it's not, it's like assuming there's one type of racking system for one roof. There's one roof in the world, and you're going to optimize rooftop solar by having like a specific racking system. Like, that's going to work for a very small set of applications. So it's this balance between getting to a point where you can minimize unique engineering per project or per system to get that cost, to scale the implementation time, to make it a holistic approach, but knowing it's like mass customization, I guess. So the edges, you're going to probably need to have like a really creative way on how you're molding it to the end user. So whether that's kind of like I said, what the marching orders are for the operating system, depending on what the end user needs, or someone prioritizes reliability over renewable production. And that's a big open question. Like, the value proposition that people are looking for is it's all over the place right now, and there's a lot of work to do to really figure that out. So I think like the existing rooftop solar market is a great example of how people are willing to try something new, like an alternative to supply from the grid. But it has a long way to go into being like a really dynamic, exciting alternative, and I think that's what we're really focused on. Like, we think people deserve a lot more.
Okay, yeah, you.
With Necker Island, you have a population, needs, and so on, and you design for that. However, things don't stay static.
Correct, yeah.
I think of the California, the freeway system. I remember reading about it way back yonder, and what we need is something, to adjust for the future.
Yeah.
So I'm curious about how you sort of interface with the changes that are likely or surprises as time goes on. You can do a pretty good job for a specific thing, but how do you take into account where it may be 10 years from now?
That's a great question. And there's so many things that could surprise us, right? Whether it's, if you draw a circle around a site, how that load, I'll sound a little bit technical right now, but how that site is used over 20 years. There's different people there, or there's different load profiles, or a fire happens, or anything could happen. Also, assuming that stayed the same, meanwhile, your options of technology to plug into it is changing rapidly too over the next 10 years. So you might have a great storage technology now, but in 5 years you want the better one that's not, as toxic and is way cheaper or better performing. So constantly, and so designing a new grid, you're right, that's a great point, that right now if we're trying to overhaul a grid, we're not trying to overhaul it and just have it stay for the next 100 years like the last one did. It needs to be this dynamic, adaptive thing. And so I think kind of focusing on the knitting together and the integration of it, which is mostly software and controls and data, and having that being quickly and easily adaptable, so that the kind of the hardware stuff of it is actually the less important side and is replaceable. I think that's our theory of how to adapt to these changes. And then again, the business model needs to go with that. So there has to be the right financing infrastructure around it, or people pay for things differently for that adaptability. Because you can't go get a PPA knowing that something's going to change in less than 20 years right now.
Okay, how about right here, and then we'll go over here.
So I wanted to ask, it seems like the approach is building everything from the ground up, creating all these pieces, putting it all together, coming up with some great demonstration projects that can show communities and businesses that these distributed systems work and work effectively and are desirable. And so you talked about getting to point A. Is that point A of having a bunch of very successful demonstration projects that encourage people to push for new regulation?
That wasn't how I was thinking about it, but I might revise it based on your description. I think it was, my original thought about getting to point A was like having a space and a freedom and a team to go tackle it. What you described, I guess I was assuming point B or something, 8.5, but it's,
Can you get to point B without also having some kind of top-down approach, new regulations and with industries adopting?
I think so, yeah. So there's, I have several, depends on what level you're talking to me about what we really think can happen. But the good thing about having like I think it can all happen kind of simultaneously. So we could go just put a bunch of stuff out there and get in trouble, but like raise the point because everyone wanted it. That seems to be a familiar approach around here, right? And that there's value to that. Like it's, it works. It like shines a really big light on a problem or something that's easy to like ignore. Or we can, which is, and I think this will happen in parallel, or there are some more progressive kind of conventional partners out there that actually listen to what their customers want. So we have this great partnership with a Vermont utility that just like gets it. And it's way easier to partner with them than it is to just go like mess with them, Or you can go to places, like my big thing is like what states don't ever think about this stuff, because then that means there's no policy preventing it, Like that's where we should really focus. Like screw California, it's way too regulated. Like let's go to Idaho, like I don't know. There's a few states, but like there you can kind of tackle that problem too, where people didn't even know it was a problem. By the time you put it in, they're like, oh, that's cool. And like that's another way to do it too. So I think there's a lot of stuff, and by having littler things, you can kind of try that more easily. So I would say like we'll probably tackle it a few ways, and it's in the country or internationally, it's all different. The regulatory environment's different, the stakeholders are different, people want different things, so you also have to adjust your approach strategically too.
Okay, we'll go back to you, and then we'll come.
Whenever you're matching up your supply and your demand profiles, were there any real head scratchers on the consumption side? Like, what the heck is this come on at 2 o'clock in the morning?
Oh, yeah.
Everybody should be
asleep. That exact example. Yeah, at our, yes, happens. It happens. Yeah, it's weird. It's sort of like, there is going to be sort of load is like very revealing. So, I mean, when I was at Google, we would never talk about our electricity load because people could back engineer how many data centers we had. So we never talked about how much energy we consumed. Now they do, but back then, it was like, nope, you cannot have that information. So it's it's very revealing.
All right, yes, please.
It sounds like you're in the microgrid business.
Yes.
Who's your competition?
Everyone. I mean, so microgrid so we have a lot of frenemies, I guess is the best way to say it. So microgrids, that word is actually, we barely use it anymore because it's confusing. And like I said, we're focused on just like distributed intelligent things that are optimizing resources. Microgrids can be something that's like islandable. There's microgrids 1.0 out there in, army bases or hospitals or, so if you look at, from one perspective, all the major industrials are our competitors, but they're also our friends. You look at the other side, it's, any distributed energy company is our, potential competitor or potentially friends. It's kind of like everyone. So it's the partnership strategy we have is like very delicate because you never know, but just focusing, but then it just kind of focuses you on finding the best the best technologies and offerings, so you don't have to worry too much about competition. But yeah, it's up for grabs. It's an exciting time.
Okay, we'll take one more question. Yeah, you.
I'd be curious to hear how you measure impact in your group, and what you define as success a year from now, 2 years from now.
Yeah, so eventually we would like to start making money. So that's one measurement. Hasn't quite happened yet. That's okay. I think there could be a lot of, we have theories as to what that impact and success will look like in 2 years. But it could be, it could be the number of systems we see out there. It could be, revenue generated by a fascinating business model we came up with. It could be the fact that, maybe NRG has invested, tons more cash in us to grow and triple or quadruple the size of our team. Maybe some of the IP we generate is licensed, from our competitors and friends. There's a lot of ways, but I think we're very product focused and want stuff out there. I think that definitely stems from my engineering training. It's really nice to see results of your work. So looking at stuff and pointing at stuff is one part of it, but that could also just be showing the number of licenses or the number of customers we have as opposed to the number of kilowatt hours.
Okay, all right. So just an announcement for the students. Please sign the sheet in the back before you leave. And on next week, we'll give you the requirements for the class. But basically, we expect you to be here every lecture. So anyway, with that, let's thank you very much. That was great.